Graph the parabola. Give the vertex, axis, domain, and range. Here we have the parabola x is equal to 2y squared plus 8y plus 3. Notice that we have x to the first power, however, y squared. This is going to be a sideways opening parabola. Let's determine the vertex by completing the square. So let's start here on the right side, and I'm going to factor 2 away from that y squared term. Writing this as 2 times y squared plus factor 2 out of 8y, so that's a 4y. Let's leave some room for completing the square, and let's just write this plus 3 outside that parenthesis. Now, look at your middle coefficient, which is 4. Half of 4 is 2, and 2 squared is 4. We need a plus 4 in here to create a perfect square trinomial. I'm going to balance out the fact that I've put plus 4 in there on the same side with a minus 4. Those counteract each other. Now, let's rewrite as 2 times y squared plus 4y plus 4. Let's move this negative 4 out of the parentheses, but realize that it's multiplied times 2. So let's write plus 2 times negative 4 and plus 3. Now factor, this is 2 times y plus 2 quantity squared, negative 8, and 3 is a negative 5. So we're ready to locate our vertex now. This vertex is going to have a y value of negative 2, an x value of negative 5. Change this sign, leave that one alone. So vertex, negative 5, negative 2. Let's locate that point on our graph. As I mentioned before, this is a sideways parabola. It has a leading coefficient of positive 2. It's going to open to the right. I'd like to get just one other point on here to use as a reference point. So in our equation for our parabola, I'm going to let y equal 0. Watch this. So in x equal 2y squared plus 8y plus 3, if y is equal to 0, those terms disappear, don't they, and give us x equal 3. So this parabola also goes through the point at 3, 0. That helps us determine how wide or narrow it is. Now let's graph, sending our parabola through that point, trying to make it symmetrical so it looks the same below. This parabola is going to be symmetrical about its axis. The equation of that axis is y equal negative 2. Let's lastly denote our domain and range. The domain is the x values used, and they are from negative 5 inclusive to positive infinity. The range indicates the y values that are used, and they are from negative infinity to positive infinity.